Okay, now this will be your answers for the chemistry practical 2018 combined science chemistry exam. Please go through the answers, and maybe after that you can watch the video to see how the experiment actually is carried out for the different tests. So for the first part, first test part A, you're asked to add about 2 cm cube of solution Q into a clean test tube, and then after that you add about 1 cm cube depth of dilute nitric acid and shake the mixture. Now once you do that, you should be able to see that the orange solution turns colorless upon addition of the dilute nitric acid. So this will be the first observation. Now to this same test tube, right, you're asked to add about 1 cm cube depth of aqueous silver nitrate. So you need to understand, okay, by adding your aqueous silver nitrate, right, we are actually testing for your chloride ion or maybe iodide ion. Okay, so when this happens, what can you see? Okay, when you add this in, the solution will remain colorless. So you can see right over here, orange solution already turned colorless. So from here, I have colorless solution. Colorless solution remains colorless. Okay, so upon the addition of your aqueous silver nitrate. So this is 1 mark, this is 1 mark. So what does this tells me then? This tells me that my Q does not contain chloride ion. Okay, it does not contain chloride ion. Now moving on, right, to B part 1, I add about 2 cm cube of Q into a clean boiling tube, and to this clean boiling tube, add about 2 cm cube depth of solution R slowly with shaking. So what will you be able to observe here? Now you will be able to see that a reddish brown precipitate is formed upon the addition of R. So this is how you should be recording your observation. Okay, I already mentioned this before. And during this process, bubbles of colorless gas are actually produced. So you will need to test for the gas itself. Okay, like what I've mentioned before, the 3 most common gases: carbon dioxide, hydrogen, and oxygen. Okay, so the 2 most common one is actually carbon dioxide and hydrogen. So if you have any doubt, honestly, you should test for these 2 gases first, and if you really have no idea what's going on, right, then you can proceed to test for the rest if you can't get a positive test. So in this case, right, we actually test for carbon dioxide. You will see that the gas produced form a white precipitate in lime water. So actually this gas is carbon dioxide gas. Okay, now to this same test tube, we are asked to add dilute sulfuric acid slowly with shaking until no further change are seen. So if you continue to add with shaking, right, this brown color precipitate, reddish brown precipitate, actually dissolves to give a yellow solution. Alright, I have a wide range of answers. Some of you say, oh, brown precipitate turns brown, reddish brown precipitate turns into a reddish brown solution. Okay, no such thing. How can a precipitate turn into a solution? The precipitate must dissolve. Alright, so you gotta make sure that you record your observation very clearly. And on top of that, right, you are asked to label, okay, the solution remaining in the boiling tube will be solution X. You are asked to label boiling tube as X. Now during this process, when you add sulfuric acid, actually bubbles of colorless gas are also produced. And if you go and test for the gas, again, the gas produced, right, actually will form a white color precipitate in lime water. So over here, right, I have a total of 1.2.345 okay, 2 plus 4. So the first page will have total of 6 marks. Now I move on. So based on whatever you have tested, you are asked to use your observation in B part 1, deduce the identity of the N ion that is present in solution R. Explain your deduction using evidence from your observation in B part 1. So what is the N ion present? In this case, the N ion that is present should be your carbonate ion. How do I know? So explanation wise, right, you need to use the TOC method. Okay, so you mention which test is it from. So from test B part 1 over here. From test B part 1, what do you do? Upon adding your dilute sulfuric acid, the gas produced, okay, colorless gas is produced, and the gas produced from a white color precipitate in lime water. Hence, carbon dioxide gas is actually produced, and this indicates the presence of your carbonic ion. So your anion that is present in R is your carbonic ion. And then for part 3, you're asked to consider all the observations you made so far, right? And explain why the anion deduced in B part 2 over here cannot be present in solution Q. Over here, right, I have my carbonic ion that's present in R. Okay, so what happens when I add acid to a carbonic ion? You should have carbon dioxide gas that is produced, alright? Because metal carbonate react with acid will give me salt, water, and carbon dioxide gas. Now if you go back to the first test over here, Q, the first thing we did was to add dilute nitric acid to Q. Okay, and over here we do not have any bubbles of colorless gas that's produced. Therefore, if we consider in test A, right, when acid is added to solution Q, there was no production of gas. Therefore, carbonic ion cannot be present. Now, if some of you, right, you all give this first part as a wrong answer, then I'm very sorry. Okay, I think for certain answer I be able to give a ECF form. Okay, arrow carried forward, but for some I will not be able to give. Okay, because your conclusion is totally wrong. All right, so let's move on to part C. Now for part C, right, you're asked to add 1 cm cube depth of X into a clean test tube, and then to this test tube add 3 pieces of your granulated zinc. Now please take note, class, I think I mentioned this to you at the start of the practical. When I add a metal, okay, for example, it can be a powder form, it can be granulated, or maybe a ribbon or strip, doesn't matter. When I add metal, what am I supposed to observe? Most of the time, it is going to be an acid plus metal reaction. Okay, so this can be with, let's say, acid, or it can be, okay, it can be a displacement reaction. That means that maybe my solution X, right, contains a metal cation and of course an anion. So therefore I'm looking at and I'm seeing whether my zinc will be able to displace the metallic cation that is present in solution X. Okay, and I want to make observation. And you take a look at the next info. They ask you to allow the mixture to stand for several minutes. So this is actually a very big clue, okay, that maybe this is going to be a displacement reaction, because displacement reaction actually it takes times to complete. Okay, not like acid reaction where once you add an acid to the metal, you'll be able to see the gas, which is your hydrogen gas that is being produced straight away. All right, so over here, what will be the observation? So again, once you add this in, right, actually you'll be able to see the bubbles of colorless gas is being produced. So if you test for this gas, right, again, like what I mentioned, right, you have a metal, you should be testing not for carbon dioxide gas. In this case, you should be testing for hydrogen gas first, because you have a metal you add to something. Okay, what are some of the reactions that you have learned? Okay, all the reactions that you have learned in the chapter on metal, right, has to do with hydrogen gas that's being produced, either with water, okay, either with acids. Most of the time hydrogen gas is produced, and in this case, this bubble of colorless gas are being produced, the gas will actually extinguish, the lightest flame will pop sound. And on top of that, right, if you leave it to stand for a few minutes, your yellow solution, it will turn green when left to stand. Okay, this can only be done after. Okay, you need to revisit this because you need to let it stand for a few minutes. Next, you're asked to carefully pour off the solution into a clean test tube and leave the solid behind. So what will you observe? First of all, you should be able to observe that my zinc, okay, my zinc will be coated with a reddish brown solid. Now that is not rust, okay, class, that is not rust. I have a few of you who wrote that, oh, rust, the zinc has turned rusty. No, first of all, iron is the only metal that rusts. Okay, secondly, this reddish brown solid that somehow coats around the zinc basically shows you that a displacement reaction has taken place. Okay, and that solid that is formed, that's basically formed out of the solution itself. That means that my zinc is actually more reactive than the solid. Okay, it has displaced that metal itself. So in this case, I'm going to guess since it's reddish brown, it's most likely going to be copper. Okay, now what else? Other than the solid form, right, the other observation that you can make is of course the color of the solution. So the solution is colorless. Okay, so I have few observation here for you to score 2 marks. Okay, last part. Now for the last part, C part 2, you are asked to add 1 cm³ of solution X into a clean test tube. Add dilute sodium hydroxide with shaking until no further change. Now this one is a standard test for cation. Okay, you're going to test for what cation is there in your X. So I don't know why this is a giveaway mark and yet some of you are not recording it properly. I already told you when I have addition of dilute sodium hydroxide or aqueous ammonia, you need to tell me 2 observations. 1. After you add a few drops, what is the observation? 2. In excess, what happened to the precipitate, if any? Okay, so reddish brown precipitate is formed in this case upon addition of a few drops of aqueous sodium hydroxide, and then the precipitate is insoluble in excess sodium hydroxide. Alright, this is 1 mark. You don't give me this part over here, you don't get any marks. Now secondly, you're asked to add 2 pieces of aluminium foil. This is a very big clean. You're adding aluminium foil to sodium hydroxide, and then after that we're going to warm. So basically over here, right, this part, like what I have explained before, this is actually a test for your nitrate ion, NO3 minus ion, to see whether it's present or not. And if you take a look at the practical paper, when we test for nitrate ion, if it is present, that means that ammonia gas is going to be given off. Okay, we're going to need to test this with a moist red litmus paper. So I don't understand why so many of you are testing for other gases that are being produced. Okay, this is a test for nitrate ion. I just test to see whether ammonia gas is produced. That's all. Alright, so when you do a practical, you really need to understand what's going on. You do not just anyhow you see any gas that's produced, or then just test for any of the gases that you want. Okay, you gotta back this up with some logical deduction first before you do anything. Okay, so over here, right, I don't need to test for any other gas other than ammonia gas because I know this one is a test for nitrate ion. So over here, I have colorless pungent gas is being produced. Okay, and the gas turns moist red litmus paper blue. So 2 marks over here. Now, you are asked to use the observation to deduce the identity of salt Q. So again, this is not a deduction question. Please use your TOC framework, which is what test are you talking about? The observation. Basically, you just copy the whole thing, right? So in this test, C part 2, so what's the observation? A reddish brown precipitate is formed upon adding of sodium hydroxide and remains insoluble in excess aqueous sodium hydroxide. Please remember to write this in. If not, I will not award you the 1 mark. This indicates the presence of your iron 3 ion. Okay, not iron 2, it's iron 3 because this is your reddish brown precipitate. And then, what about the anion present? Now the gas produced, right, that when aluminum foil is added to the mixture and warmed, actually turns your moist red litmus paper blue. This indicates the presence of ammonia gas, which means that your nitrate ions are present. So 1 mark each, this will be 2 marks. Last but not least, you're asked to suggest an explanation for your observation in C part 1 in terms of the chemistry that's being involved. So over here, right, basically what's going on is that I have a displacement reaction that's taking place between your zinc and your iron 2 ions. Alright, so what happened? Like what I mentioned before, since zinc is more reactive than iron, okay, so in this case actually iron not copper, it will actually displace the iron from the solution to form solid iron and zinc solution. Alright, so this is the ionic equation.